Welcome everyone. This is an assertion reason based type of question. And let us read the options first. Two statements are given. One is assertion and is denoted by A, and another is reason, it is denoted by R. And the options are both A and R are true. That means A is correct, R is also correct. R is the correct explanation of A. That means R is basically explains the fact explained in capital A. Both A and R are true. That means A is also true, R is also true, but R does not explains A. That is, R is not the correct explanation of B. So this relation does not build up here. A is true, but R is false. That means capital A is correct, capital R is false. A is false and R is also false. A is false here and R is also false here. So this is said in the question. So after that, little bit. Yes. So after that, let us read the assertion and reason. So in the assertion it is written the photoelectrons produced by a monochromatic light. That means the light of particular frequency or particular wavelength. Incident on a metal surface. Obviously it have to incident, otherwise how these photoelectrons will commit out, have a spread in their kinetic energies. Okay. Now, what is said here? Let us consider it is a metal surface. If a photon of particular frequency and particular wavelength just incident on it, that is h nu equal to hc divided by lambda. When it just incident on it, then what will happen? Electrons, metallic electrons, which are inside this metal, which is roaming around in the metal, executing Brownian motion just like the gases, okay, absorbs it, and after that it comes out the metal surface, which is basically named as the photoelectron. And there is one quantity which is called the work function. This energy of the photoelectron should be greater than equal that of the work function, otherwise the photoelectric emission will be not possible. And it is said that the photoelectrons which are basically coming out from the metal surface have the spread in energies, have the spread in their kinetic energies. So what does it mean? It means that the energy of the photoelectron is starting from 0 to half of mv max square. That is the energy of the photoelectron which is starting from 0 to half of mv max square. It have all the values and it is continuous. Okay. So this is explained in the first statement, which is denoted as assertion. In short, it is written as capital A. The energy of the electrons emitted from inside the metal surface, the energy of electrons emitted from inside the metal surface is lost in collision with the other atoms in the metal. Obviously, it is so. Let us move to another page. And let us consider this is a metal surface. A photon of frequency nu and wavelength lambda, when just incident on it, the electrons which are inside it have different values of kinetic energy. You know that the metallic electrons basically taking the energies from the surroundings, which is called the thermal energy. And you know that the electrons within the metal after gaining these thermal energies have different levels, just like the energy levels, you know. Okay. Basically it may remind you the energies of the electrons within the atom. Maybe this is the ground, this is the ground state, this is the first excited, second excited state, like this. Okay, we have learned this. So like this, the energy levels these electrons have there. Okay, It is not possible that all the electrons are in one particular level or one particular energy value or one particular band. It may be distributed because by absorbing the thermal energies, it may be in different levels. Let us consider one electron is at that level. Okay, that is the level 1 and having the energy E1. This is the level 2 having the energy E2, and this is the level 3 which is having the energy E3. Okay, and another electron which is at the level E3. So now just try to understand if the electron which is basically absorbing the energy H nu which is at level E1, and another electron which is also absorbing the energy H nu which is at E3. Both of them have the same type of energies after absorbing it. Let us explain it little bit. After getting the energy H nu, a portion of the energy is used up in overcoming the collisions with the other electrons which is present in the metal, and after it is comes out from the metal surface and it is a statistical average, we can call it as the work function. And H nu plus equal to W0 plus half of m V max square. And what I have said just now, that is the W naught. W naught is nothing but the characteristics of the metal surface. If it is made up of a particular metal, then for this particular metal, these metallic electrons must have to lose this much amount of energy to come out of the metal surface. Okay, but just try to understand. The energy which is falls on here, it is of particular frequency, it is of particular value, it is not changing. W naught is a constant characteristics of the metal, half of m V max square, which is completely depends on the H nu, and H nu is a constant here because it is monochromatic. So just try to understand that if it is so, if the electrons are not at different levels, okay, then all the electrons after absorbing the energy H nu comes out from the metal surface with the same value of kinetic energy. But since the electrons are at different energy levels, for example, if we consider that the E3 is greater than E1, then the metallic electron at the level 3 which is here, which must have the greater energy initially than that of the electron which is at the level 1. So what will happen after getting this energy H nu, both the electrons basically loses the energy equal to that of the work function, and after that it just comes out of the metal surface. But which electron have the more energy? Okay, which electron have the more energy? The electron which is at the level 3, which is comes out from the level 3, it must have the more energy than that of the electron which is comes out on the metal surface from the level 1. That's why, except this half of m V max square, initially electrons are at which energy levels? Depending on the kinetic energy of the photoelectrons coming out from the metal have a spread in kinetic energies half of m V max square. So the assertion is correct here. Okay, that is the photoelectrons produced by a monochromatic light beam incident on a metal surface have a spread in kinetic energies. It have the values not from 0 to infinity but 0 to up to the maximum value of the kinetic energy. The energy of the electrons emitted from inside the metal surface is lost in collisions with the other atoms in the metal. Is it quite possible? It is quite possible, because just try to understand that maybe the electron which is at lower value of energy, okay, which is a lower value of energy, let us say E1, which is very low value of energy, okay. So when it gets that amount of energy, h nu from the photon, W naught is used up as a work function, rest of energy half of m v max square is used up, okay, in overcoming all these collisions, okay. So since its initial energy is low, so this energy is used up in coming out from the surface. So it is quite happens there, and that's why due to the depending on the one point, I repeat again, due to depending on the at which energy level the electron is, the electron will come out with a different range of energy. And the second statement, which is stated as a reason here, obviously correctly explains and gives the basis, a platform on which the assertion can be made. So that both the assertion and reasons are correct, true, but R is the correct explanation of the assertion. So the option A is the correct answer. Thank you all.